In this lesson, we're going to look at inverse trig functions. So basically, we're going to look at what they are and then why they're useful. So if you look at this first example here, where we know that sine of theta is equal to 0.278, and we want to find theta. Theta is a symbol right here. It's just a symbol that's typically used to find angle measures. So it's just a symbol. It's just like a variable, and it's just commonly used for angles. So if we wanted to find that theta, what we would do is we would take the inverse, what's called the inverse of sine. So we take the inverse of both sides, and it basically undoes sine. It's the opposite of finding sine of something. It's how you undo it. So then we end up with theta equals sine inverse of 0.2478. And in your calculator, depending on what type of calculator you have, it's going to have the sine to the -1. That means sine inverse. That's how we undo the sine key. So basically, you would put that into your calculator, making sure that it's in degree mode, and that would give you theta. So if you look, we get 14.347. So rounding to the nearest degree, so about 14 degrees for the angle. So what that means is if I take sine of 14, I should get out 0.2478. That's what it's saying, or close to it because we rounded here. So let's look at just a couple more of these, just understanding how to do that. So if I wanted to find the angle, and I know that sine of that angle is equal to 0.528, what I do to figure out what theta is I take the inverse sine of 0.5281, and I'm going to put that into my calculator because, again, remember, I'm taking the inverse, sine inverse of both sides is basically what I'm doing. So the sines cancel. I get theta equals sine inverse of this number, and you get about 32 degrees for that. So this one I would be taking cos inverse of both sides because I want to undo cosine, because I'm asking what does the angle have to be so that when I take cosine of it, I get 0.2249. So in your calculator, you would do inverse, cos inverse of 0.2249, and you would get theta equals about 77 degrees. And then the last one here, tan theta equals 0.8421. If I wanted to find what theta is, again, I'm taking tan inverse because I'm undoing tan. So tan inverse of both sides. So basically theta equals tan inverse of 0.8421. And that gives me 40. So if I take tan of 40 degrees, I would get out 0.84. So now let's look at how is this actually used in problems, because when will we end up with a situation like this is what we're asking ourselves. So on the next page, we have some problems where we go back to those right triangles. The difference is now we're looking at finding the measure of the angles. In the previous lesson, we looked at finding the measures of one of the sides, and we were always given an angle or given one of the acute angles. In this case, we're trying to find the angle. So in order to do that, you have to know how to use these inverse trig functions. So first thing we're going to do is we're going to label what we have. So again, looking at the right angle, hypotenuse is always across from that. And then we look at, before we would always look at the number of the angle, but in this case, I'm going to be using x. X is what I'm trying to find. So that's the angle that I'm going to label everything with respect to. So across from this would be the opposite. Next to it would be the adjacent. So when I think of this in terms of SOHCAHTOA, the thing that I don't have or don't want to use is the opposite. So I don't want to use anything with an O, which leaves me with ka. So that means I'm going to set up cosine. So cosine of the angle, which is x, which normally in the previous lesson was a number, this time it's x because that's what we're trying to find, equals adjacent over hypotenuse. So cosine of x equals adjacent 10 over the hypotenuse, which is 15. So now I'm trying to get x by itself. I'm trying to find the angle. So what we're going to do is we need to undo cosine. So we need to take cos inverse of both sides. So if I take the inverse of both sides, these cosines will cancel and you'll get x equals cos inverse of 10 over 15. And then you would put that in your calculator, making sure you're in degree mode because you're trying to get out a degree. And you should get, if we round it to the nearest degree, 48 degrees. Keep in mind, this will only work for right triangles because we're only looking at those trig ratios. They only apply, SOHCAHTOA only applies for right triangles. So this is only ever going to work in right triangles. So let's look at a couple more examples like this. So at this for this example, again, hypotenuse across from the right angle, we can always label that. And then go to wherever the angle is that you're worrying about, which in this case, x. Opposite is across from that. Adjacent is next to it. So when I think of this in terms of SOHCAHTOA, we have the hypotenuse not being used. So anything with an h in it, we won't use, so we're going to be using tan. So tan equals opposite over adjacent. And it's going to be tan of x, because you always take the trig function of the angle. So in this case, my angle is x. So tan x equals opposite, which is 5 over 12. Now we have to undo tan, so we're going to take the tan inverse of both sides. So the tans cancel, I get x equals tan inverse of 5 over 12. Put that into a calculator, and you should get, if we round to the nearest tenth, 22.6 degrees. And you have to make sure you're in degree mode so that your calculator is spitting out degrees. Even though I'm not putting in degrees, I want the answer to be degrees, which is why it needs to be in degree mode. So let's look at just one last example like this. So I'm starting at solving for angle B. So angle B is going to be my x. So that's where I'm labeling everything in respect to. So across from is the opposite. Hypotenuse is always across from the right angle. Adjacent is next to it. So again, thinking of this in terms of SOHCAHTOA, sine, cosine, and tangent. When I'm looking at this, I'm never going to be using adjacent, so I'm not going to be using anything with an a, so I'm going with sine. So sine of x equals opposite over hypotenuse. I just called this an x instead of angle B. You could put angle B there if you wanted to. So now I have sine x equals opposite 3 over hypotenuse of 5. Now we're going to take the inverse of both sides. So we have those cancel. X equals sine inverse of 3/5. So when you put that into your calculator and you round to the nearest degree, nearest whole number, you get 37 degrees. So the measure of angle B is 37 degrees. And I'm just making sure I write that last statement because it said to solve for angle B. So I should answer it as the measure of angle B is this number. So then let's look at one last type of problem here. And the last type of problem we're going to look at is what happens if you basically combine this lesson and the last lesson. So basically you're given a picture and you're trying to find anything that's missing. So missing angles, missing sides. So you have to kind of combine some different ideas. So let's look at a couple of these just to see how we would set them up. So this first one here, we're trying to find everything. So we're trying to find the missing sides, x and y, and the missing angles, 1. There's no missing angle number 2. We have the other angle. So first thing I'm going to do is I'm going to find the missing angle. That's easy for me to find right away. So I'm going to find the measure of angle 1. To do that, there's a couple things you could do. You could do what we just did, and you could do the whole right triangle trig. But the easiest way is just to know that all 3 angles in a triangle add up to 180. So I can just do 180 minus the angles that I already have. I know that this is 90, so I can subtract that off. I could subtract off the 37, and whatever's left, which happens to be 53, is going to be the measure of angle 1. So the measure of angle 1 has to be 53 so that all three angles add up to 180. So that's the easiest way. It's not really using trig, but let's just go the shorter way of doing it. You could do SOHCAHTOA, but you'd have to find one of the sides first, and then you would use SOHCAHTOA, but this is much quicker. So then let's look at the next thing. So we found angle number 1. So now let's look at finding one of the sides. So let's just start with x. It doesn't matter. I could have done y. So if I want to find x, that means I need to pick an angle to use. So I'm going to use angle 37. I could have used 53 if I wanted to, but I just chose 37. And I have to look at x and the 15. So I'm basically ignoring the y for right now. So if I'm looking at this, this is the opposite. 15 represents the hypotenuse, and y represents the adjacent. So if I'm trying to use, SOHCAHTOA, if I'm trying to use the 37 and I'm trying to use the x and the 15, I'm not using the adjacent. That means I'm going to be going with sine because I'm not using anything with an a in it. So that tells me that sine of 37 has to equal the opposite, which is x, over the hypotenuse, which is 15. So I'm just using my formula. Sine equals opposite over hypotenuse. And then we solve for x. So we end up cross multiplying. So 15 times sine of 37 equals x. So x ends up being, I'm going to just round it like 2 decimal places, 9.03. And now the only other thing we have to do for this problem is we have to find y, the other missing piece. So finding y, we start over with SOHCAHTOA. We can still use that same angle 37, or you could switch and go to 53 if you want, but I would just stick with 37 since we already have everything labeled. And if we're using angle y this time, we could really either use, we can decide if we want to use the hypotenuse or the opposite, because I know now that this is 9.03. So technically I could use this, but I would still recommend sticking with the 15 for your side along with y, only because this is rounded and it's not an exact answer. So I would stick with saying let's just use the hypotenuse and the adjacent, which means I'm not going to use the opposite. So I'm not going to use anything with an O. So that means I'm going to be using cosine. So cosine of the angle, which is 37, has to equal adjacent, which is y, over hypotenuse, which is 15. So I didn't use the x, I didn't use 9.03 because it's a rounded answer, and I stuck with y because that's the variable I'm solving for, so that has to be in there, and then use the 15 for the other missing side. So you always have to have one side and one unknown if you're trying to solve for the side, and then the angle you have to have. So now I can cross multiply. So 15 times cosine of 37 equals y. And then we would just put that into our calculator. Again, I'm going to round 2 decimals. So 11.98 is what we get for that. So that would be it for that. Let's look at just one more of these just so you can see another version of it. So in this example here, we're trying to find missing sides. This is y and z, but really we're just trying to find missing side z and the missing angles 1 and 2. So first thing I'm going to do is I have to figure out one of these angles, because we can't figure out the side z unless using SOHCAHTOA unless we know one of the angles, one of the acute angles. You could use the Pythagorean theorem to find z. 8 squared plus 9 squared equals z squared. You could do it that way, but I want to use right triangle trig just to keep it fresh. So what I'm going to do is I'm going to start with, let's find the measure of angle 1. Let's start there. So I have to think of this in terms of SOHCAHTOA, because I can't just subtract the angles from 180 this time, because I only know one angle. I only know the 90-degree angle. So if I do 180 minus 90, all that's telling me is that these two angles have to add to 90, which we already know that. So we have to say, well, if I'm starting with angle 1, let's look at our pieces. Let's label the different pieces. So this is going to be the opposite. This is going to be the hypotenuse. And this is going to be the adjacent. So if I need to find angle 1, I would be using the 9 and the 8, which means I'm using the O and the A. So I'm going with tan. I won't be using the hypotenuse. So tan of angle 1 is equal to the opposite, which is 9, over 8. Opposite over adjacent. So now I need to get angle 1 by itself. So what that means is I need to take the inverse of tan of both sides so that I can get angle 1 by itself. So angle 1 is equal to tan inverse of 9/8. So the measure, the little m stands for measure of angle 1, would be, if we round it to the nearest tenth, 48.4 degrees. And then from here, if you want to find the measure of angle 2, and you don't want to have to relabel everything and use trig, the shortcut would be to do 180 minus each angle, 48.4 degrees minus 90 degrees, and you end up with 41.6 degrees. So the measure of angle 2 is 41.6 degrees. Now, you could do SOHCAHTOA again, and basically like what we just did to find angle 1, and you should get the same measure, but it's quicker once you know one angle to find the third angle, just subtract them from 180 instead of going through the whole SOHCAHTOA process if you don't have to. And then the last thing we need to find is z. So to find z, we're going to use SOHCAHTOA. So we have to decide, so this time I have angle 1, I know that it's 48.4 degrees. So I know the opposite and I know the adjacent, and I'm trying to find the hypotenuse. So basically you just have to pick what you want to use. So let's say I want to use the opposite. I have to use the hypotenuse because that's what I'm trying to find. So I have to use the hypotenuse, but I can decide, do I want to use opposite or do I want to use adjacent to be able to set up my proportion or my ratio here. So I chose to use opposite, so that means I'm going to be using sine. I know that I can't use tan. I could have used cosine if I wanted because I do have the hypotenuse and I do have the adjacent, but I decided that I'm going to go with sine. So I set this up. Sine of the angle is 48.4, equals opposite, which is 9, over the hypotenuse, which is z. So then what we're going to do is we're going to cross multiply. So put that over 1 and cross multiply. So z times sine of 48.4 degrees equals 9. And then we're going to divide both sides by sine of 48.4. So divide. So those cancel there, so we get z equals 9 divided by sine of 48.4 degrees. So then we put that in our calculator. Make sure you put the sign in parentheses. And when you do that, for z, we end up, if we round to the nearest tenth, we get 12.0. So that's the length of z. So this process is really going to be the same process. There's sometimes ways that you can shorten it. Like I could have found z right off the bat by doing Pythagorean theorem. That would have worked. Even as a last step, I could have used Pythagorean theorem. I had to use right triangle trig to get one of these angles. I could have done it to get both, but once you know 2 out of the 3, you can just subtract them from 182. So there's multiple ways of doing these, but it's really just kind of tying both pieces together.